How are you there? Welcome back to Think Tank Online Learning. In this video, I want to show that this function is analytic. Okay, so given that if u, x, y, and v, x, y, and remember that one complex functions, so that means u is the real part and v is the marginal part. Okay, so I want to determine if this is analytic. Okay, so what are we going to do? Okay, so first of all, we are told that if u, x, y, and v, x, y are harmonic. Okay, so this is the keyword which we're going to use, harmonic. And what do we know about harmonic functions? Okay, so for harmonic functions, we know that u, x plus u, y is equals to 0. And we know that v, x plus v, y is equals to 0. And we should know that uxs means the second derivative of u with respect to x, and uyy means the second derivative of u with respect to y. Okay, so what does that mean in terms of partial derivatives? Okay, so this simply means partial u, partial 2u, partial x2 plus partial 2u partial y2, and this is going to give us 0. Okay, and what does that mean? That means if we want to equate this one, we're going to get partial 2u partial x2 is equal to negative partial 2u partial y2. Okay, like this one. Now we're moving to the imaginary part, and they've said we're not doing complex functions. V is our imaginary part, and for v, that means partial 2v partial 2 partial x2 plus partial v partial y2 is equal to 0. Then this implies that partial 2v partial x2 is equal to negative partial v partial y2, like that. Okay, so the reason why I'm writing this, these are some of the formulas which we are going to use. Okay, we're going to need this one. Okay, so now if a function is analytic, what are we going to use? Okay, to show if a function is analytic, we're going to use the Cauchy-Riemann equations. Okay, so I'm going to call them CR here. I'm assuming that you are familiar with Cauchy-Riemann equation, but I'm going to write them here instead. Okay, so what does it tell us? It tells us ux is equals to vy. Okay, so that means the partial derivative of the real part with respect to x should be equal to the partial derivative of the imaginary part with respect to y. And the second one, it's uy is equals to negative vx. Okay, so if these equations are satisfied, that means that a function is analytic. Okay, like this one. So if you haven't subscribed to this channel, just make sure you click on the subscribe button, and don't forget to turn on the notification bell so that you don't miss our next videos. If you're looking for other videos like this one, just go to Think Tank Online, and you're going to go to the playlist, and you're going to see a playlist named Multivariable Calculus. You're going to see many videos like this one. Okay, so first of all, what I'm going to do, I'm going to start with the ux. Okay, and you know what is my uxy? So my uxy, that means that u is a function of x and y. So these are the variables of the function u, which is the real part. Okay, so is what is partial u partial y minus partial v partial x. Okay, so this is my function. Okay, so these are the parameters or the variables that are in the function of u with x and y. But unfortunately, we're given that in terms of partial derivatives. Okay, so what I'm going to do, I'm going to find the partial x. So that means I'm going to differentiate this with respect to x of the function of the u function, which is partial u partial y minus partial v partial x. Okay, like this one. Okay, so first of all, we're going to differentiate this with respect with respect to x. Okay, so what I'm going to have here, I'm going to have, let me write that in blue one. So I'm going to have partial 2u here, and partial x and partial y, that is partial x, partial y. Okay, what about here? I'm going to have partial times partial, that is going to be partial 2v, and I'm going to have partial x and partial x, so I'm going to have partial x2. Okay, so this is the answer for partial x of u x y. Okay, so I'm going to need this. Let me put it in a box. Okay, so now I'm moving to partial y of u x y. Okay, and that's going to be the partial y of, and this is our uxy of partial u partial y minus partial v partial x. Okay, so what are going to have here? So for partial, I'm going to have partial 2u, and for partial y and partial y, that's going to give us partial y2 minus partial v, that's going to be partial squared v, and for partial y partial x, it's going to be partial y partial x. Okay, so I've said this is the partial y of u x y. Okay, so now I'm done on the rule part. I'm moving on to the imaginary part. Okay, so for the imaginary part, I'm going to do the same. Imaginary part, which is here. Imaginary part of the function. Imaginary part, which is v x y. Okay, so for the imaginary part, I'm going to start with partial x of v x y, and that is equal to the partial x of what is v x y, which is partial u partial x plus partial v partial y. Okay, like this one, and we're going to differentiate this one, so we're going to have partial 2u over partial x2, this is partial x and partial x, plus, and we're going to have partial 2v over partial x partial y. Okay, like this one, and this is the partial x of v x y. Okay, so now on the rule part, I have done partial. I differentiate the rule part with respect to x. Now I'm going to differentiate it with respect to y. So it's going to be partial y. Okay, so vxy is right here, which is partial u partial x plus partial v partial y. Okay, so I'm going to do the same. Partial, we're going to have partial squared u. Okay, this is actually u. We're going to have partial y partial x, you say partial y times partial x. We're going to have plus, we're going to have partial 2v, and we're going to have partial y times partial y. That is going to give us partial y squared, and that is partial y of v x y. Okay, so let me put it in block. Okay, so now we have our ux and uy, and we have our vy, and we also have our vx. Okay, so now what do we need to do? We need to see if these equations are the same. Okay, So what I'm going to do, I'm going to start with ux is equals to vy. Okay, so for ux is equals to vy, let me write it here. Ux is equals to vy. Okay, and what is my ux? So my ux is right here. It's partial. Let me write that one in red. So we're going to have partial u, partial x, partial y minus partial 2, partial squared v. Okay, this is partial 2 dx2, and I want to see if this is equal to partial y to vy. Okay, so for vy is right here. It's partial 2u partial y partial x plus partial 2v partial y squared. Okay, so as you can see, we have a negative v and we have a positive v. Okay, and this seems like it's not the same, but it's the same. Why am I saying the same? Let's go back here. Okay, so from here, what are we seeing? Okay, so from here, from the questions which you have written for our harmonic equations, we have said uxx plus uyy is equals to 0. So what does that tell us? Okay, so here we have partial u, partial x, partial y, and we have partial 2u, partial x, partial y. Okay, that is the same. But we have a negative v and we have a negative v. But we are told that positive partial 2u partial x2 is also equal to partial negative, is equal to negative partial 2u partial y2. Okay, so as you can see, this negative is equal this positive according to the harmonic equations. Okay, so that means you can say the first CR or Cauchy-Riemann equation is satisfied. Now we want to move on to the second one. Okay, so to the second one, what we're going to do, we're going to say v, this one which is right here, uy is equals to negative vx. Okay, so let's go to uy. Okay, so for uy is right here. Okay, so uy, I'm going to write partial 2u divided by partial y2 minus partial 2v partial y partial x is equal to the negative, remember we have a negative here, vx. What is vx? So this is vx. So for vx, what do we have? We have partial 2u partial x2 plus partial 2v partial x partial y. Okay, like this one. And this is the same. Okay, so let's see. If multiply here by negative, this one is going to become negative. Okay, but here we have a positive, and this is also going to become a negative. So if this becomes a negative, it is going to be equal to this one. Okay, there's no doubt here. But what is happening? This one is a positive, but this one is going to become a negative. Okay, we're still going back here to harmonic equations. We're also told that the partial 2v of partial x2 is also equal to the negative of partial v over partial y2, as you can see right here. Okay, I think I've omitted a squared here. Okay, and right here. Okay, like this one. So as you can see, the negative of partial 2v and partial y partial x is also equal to the positive of partial 2v partial y partial x according to the two harmonic equations. Okay, so that means this is also satisfied. So now what only left is to write a conclusion that according to the Cauchy-Riemann equations. Okay, so now what is left is just write the conclusion. Since the Cauchy-Riemann equations are satisfied, that means we've proved that this function is analytic. Okay, so thank you for watching, guys. If you enjoyed if you've benefited from this video, I encourage you to subscribe so that you can support us. If you have anything you want to say, or if you have something you want to add, you can just type that in the comment section. Okay.